Hello, this video is for IXL activity 8.V.15. It is titled Add and Subtract Like Terms. Now, I personally kind of like to think of this more as combining like terms. You may have heard the term combining like terms in the past, and that's what this is. We're adding and subtracting like terms, combining like terms. Pretty much the same thing. The 3-character code for this activity is Quebec Papa 7, QP7. So in previous lessons, we talked about what are terms. Those are our values that we have that are separated by the addition and subtraction signs, because we know that a subtraction sign can be changed to addition. So technically, it is the sum of each of the items that we're adding together, such as the 4x squared or the 14x or the 7xy. These are all terms. They're separated by the plus and minus signs. So we can see here we have 1, 2, 3, 4, 5 terms in this first expression across the top. And then that'll simplify down to 3 terms. Those 5 terms can become 3 terms. And we do that by adding and subtracting those like terms, or another way of stating this is that we are combining like terms. Now, we also talked about what is a constant, and actually there's no constants in this one here. Remember, a constant would be a number without any variables. And we also talked about what a coefficient is. A coefficient is that value that sits out in front of the variable. We like to have them before the variables. If we have such as 3x, we want to write it as 3x. We don't want to do it as x3. And since the 3 comes before the x, we refer to the value or the coefficient. We often refer to it as the leading coefficient. We like it to come first. So you can see here that the 4x squared and the x squared have been put together into 5x squared. Well, remember that anytime you don't see a leading coefficient on a variable, such as this x squared here, remember we can multiply it by 1. We could put a 1 in front of that, and then we would have, at that point, we would have 1 plus 4 equals 5. So this is where we get the 5x squared by combining 4x squared and 1x squared. Now, another interesting thing to note is that the terms have to be identical. That is to say, if you were to remove the numbers, consider this 3xy and 7xy here. If we were to remove the coefficient or the leading coefficient, such as the 3 and the 7, would they look absolutely identical? And here we have xy and here we have xy, so we can combine those. So 3 plus 7 is 10, and that's where we get this 10xy, is by combining the terms 3xy and 7xy. They are in terms of xy. We would state that as they are in terms of, and then we say whatever the variables are, xy. Now notice that this 14x is the only term of x. Now you might say, well, there's just an x after the 14, and there's an x after a 4, and then there's the x over here. Why can't we put those together? Well, that's because the 14 is just 14x, whereas in the green here we see this is x squared. Again, they have to be absolutely identical. If we remove this 14, we just have x. If we remove the 4, we'd have x squared. So we can't put an x squared and an x together. Those indeed are not like terms. So let's go ahead and move along to our first question. Here it says to simplify the expression. Remember, simplify means we get it down to where there are no grouping symbols and all like terms have been combined. So with that said, we have a term of r and a term of r. So both of 3r and 10r, they are like terms. We can combine them. So we will then add together the 3 and the 10. And 3 plus 10 is indeed 13. 13 what? 13r. Have to bring the variables along for the ride. So next one, we have terms of g. And, well, notice this is subtraction, right? So let's change this subtraction over to addition. And this is 9g. We're going to change the sign to addition, then take the opposite of the value that follows. Well, 2g follows. It's positive, so we'll make it negative. So we have negative 2g. So now we see that both of these are in terms of g, and then we combine the 9 with the negative 2. Well, that's 9 minus 2, right? So we end up with 7. 7 what? 7g. All right, on the next one, I do have a couple subtractions here. So eventually you'll get to where you don't really have to change this over to sums. I'll do it early on here, and then in some problems later we'll start talking about how can you kind of do that mentally without actually having to rewrite it. So I'm going to change this over from 10c squared, change the subtraction to addition, take the opposite of c squared, which is minus c squared, and just for a memory device, remember that this is actually a 1 can be in front of it, so that's like negative 1c. Now let's change this here, this one here, subtraction sign over to addition. The opposite of this here, 10c squared, is negative 10c squared, and then bring down the plus 4c. Plus 4c squared to be exact. So it looks like, well, check this out. They're all in terms of c squared, aren't they? So all 4 of these are like terms, so we are going to combine all of them. Well, I'm noticing that I have 10c squared and a negative 10c squared, so those are going to cancel each other out, right? Because if we add 10 to a negative 10, we're going to get 0. So those just cancel each other out, and we end up with negative 1 plus 4. So we can see here we have this negative 1, and so in our mind, we don't have to really write it to the side. I'm just kind of showing you my mental math. So I can have negative 1 plus 4. All right. Now, I could think of this as I start on a number line at negative 1, and here's 0, and then I'm adding 4, and that would get me to 3. Or another way for us to realize it is it's addition of a negative and a positive number. So we take the one with the greater absolute value and subtract from it the other value. And so 4 minus 1 is 3, and the 4 has the greater absolute value, and it's positive, so our answer is positive as well. So our answer of negative 1 plus 4 is positive 3. 3 what? Got to bring that term of c squared along. So 3c squared. On the next one, looks like I have all of them are in terms of x. And what they're asking you here is, do you realize that there's a 1 in front of each of these? So we could realize that this is negative 8x plus negative 1x plus negative 1x. So we end up, we have to add together negative 8, negative 1, and negative 1. Well, they're all negative, right? So we're just going to add them all together. 8 plus 1 is 10. And they're all negative, so it just gets more negative, so the number's still negative. Negative 10 what? That's right, we have to add that term of x on there, so negative 10x. Let's look at the next slide here. Starting to get 4-term questions, and they're not all the same terms. So I always like to focus on the variable terms first. We do have some constants here, like the 4 and the 10. Those have no variables with them. We call those constants, and the reason that we call them constants are that the value is not going to change. This is constantly going to be equal to 4. The 10 is always going to be equal to 4. It's constantly going to equal 10. However, this term here could change all depending upon what the value of g is, and likewise, this term could also have a different value all depending upon what the value of g is as well. So let's go ahead and combine our terms of g squared first. So we have a 2 and we have a 7. Notice that all of these are addition, so we don't have to worry about changing anything over there. So 2 plus 7 is 9. 9 what? 9g squared. So we've taken care of this one here and this one here. That leaves us with our 2 constants remaining. 4 plus 10 is 14. So our final answer is 9g squared plus 14. All right, on this one here, I'm going to kind of not really write it all out rewrite it because I do have a subtraction sign here, right? So I'm going to kind of model how to do this one mentally. Mentally modeling. All right. So I realized that in my head, I'm going to realize, okay, this is like plus -2, right? And so I can go with that. So let's see what terms I have that are like. I have b squared, b squared, b squared. So the first, second, and fourth terms all need to be combined. So I have 9, -2, and 3. So 9 plus -2 plus 3. So I might want to, I'll just work from left to right. We'll do that. So 9 plus -2 is going to be 7. And then 7 plus 3 is going to equal 10. So I have 10. 10 what? 10b squared. And then that leaves me with the plus -2. Now I could put plus -2, but it would look a little more proper if we just made it -2. So I changed the sign, right? And then I took the opposite of the next number. So change addition to subtraction. The opposite of -2 is +2. So -2 is the same as plus a -2. Combine any like terms in the expression. If there are no like terms, rewrite the expression. So what if they gave us something and there were just nothing to combine? It was already simplified. I guess my point is what if the answer, what if the problem was the answer? Because there's nothing you can combine, or there's nothing that could be simplified. So, or I'm looking down the next question here. What if it all just goes away? What do we do then? So we have here a 9s, and remember this is plus a negative, right? So I end up with two terms of s. One's +9, the other is -9. So those are going to cancel each other out, right? Those are opposites. And that leaves us with just the 2s. That was a pretty easy one, right? Check out this one here, the next one. 7CD minus 7CD. This minus this. Well, what we're taking away is exactly what we start with. Or we could think of this as plus a -7. And whenever we do that, they become opposites, right? Positive 7CD, negative 7CD. They are opposites of each other, so they cancel each other out. So you might be wondering, so what do I put for an answer? Well, what number do we use to represent nothing? That's right, 0. So the answer here would be 0. On the next one, combine any like terms in the expression. If there are no like terms, rewrite the expression. So 30WX plus 49W. So one is in terms of WX, one is in terms of W. Are these like terms? Hopefully you understand that they are not. They both have a W in them, but they don't both have an X. In order for these to be like terms, we would have to have an X right here. However, we don't have an X there, so we cannot combine these two terms because they are not like terms. So we would just rewrite it because it is already simplified as much as we can. We couldn't simplify it any further, so notice that the answer is exactly the same as what they gave us here originally. And our final question here, so I'm going to do this one a little bit of mental math here, or without rewriting the whole thing. One thing that jumps out to me right away, I know I said I like to do my ones with the variables first, but check this out. I'm seeing this 35 minus 35, or think of this as 35 plus -35. So these are opposites. Those are going to cancel each other out, so the constants just go away. Now we do have stuff in terms of, it looks like all three of these are in terms of Q, so we can combine these. And I realize that this is plus a -7, so 50 minus 7 is 43. And then 43 minus 22, or 43 plus a -22, either way you want to look at it. So 43 plus -22. So I'm adding a positive and a negative number together. So actually I'm going to subtract 43 minus 22. And 3 minus 2 is 1. And 4 minus 2 is 2. So it's 21. And note that the 43 has a greater absolute value than the negative 22. So we're going to use the sign that matches the 43, and the 43 is positive, so my answer is positive. And that makes sense. 43 minus 22, it's not enough to get you to 0, so your answer would be positive. And do not forget to bring the Q along for the ride. So 21Q is the final answer for this question. So those are all of my examples for IXL 8.V.15, add and subtract like terms, or as I like to refer to it, combining like terms. Good luck with your activity.